Welcome to LJ Institute of Engineering and Technology in the Department of Instrumentation and Control Engineering. In this session, we will discuss the subject that is Industrial Drives and Control. I am your instructor Jayesh Prajapati. In last session, we will discuss the unit number 4, that is a chopper controlled DC motor drives. Actually, we have already discussed the unit 1, 2, 3 and 4. Now, we will discuss the unit number 5, that is frequency controlled induction motor drives. In this chapter, we will discuss the AC motor drives. So here we have already discussed the DC motor drives, chopper control DC drives. So now in this session, in this chapter, we will discuss the AC motor drives. Okay. Basically, in the AC motor, we have to study the induction motor drives. Now in this chapter we will discuss the content, that is first content, that is a static frequency changer. A static frequency changer, that means we have to study a different changer circuit. Basically a AC motor can be work on AC supply, so AC supply having some kind of frequency. So we have to vary the supply voltage and frequency. So by varying the frequency, we have to vary the speed. So that's why we have to study a static frequency changer circuit. Then the next topic, that is a different types of voltage source inverter. Here in this content, we have to study different types of voltage source inverter, like half bridge converter, full bridge converter, and then modify MC Murray inverters. That kind of voltage source inverter that we have to study in this session. Then voltage source inverter driven induction motor. So here we have to study the inverter driven induction motor drive. So voltage source inverter driven induction motor drive, that we have to study in this topic. Then speed control and constant V by F control method. So we in this topic we have to discuss the different types of speed control of AC motor drives. Okay, and most popular method like V by F control method, that we have to study in this topic. And the last topic, that is a PWM inverter. In this PWM inverter, we have to study different PWM methods, and we have to study a different PWM inverter also. So here, that is a content that we have to study in this chapter number 5, frequency control induction motor drives. Now let us start with some basics of this chapter. Now the question is, what is induction motor? Now if we have to define the induction motor is an AC motor. Okay, if we have to define the induction motor, then we have to give some kind of definition. In this figure you can see that is a induction motor. Now if we have to define the induction motor, then the definition is, induction motor is a AC electric motor in which electric current in the rotor needed to produce a torque is obtained by electromagnetic induction from the magnetic field of stator winding. Okay, in the AC motor, induction motor basically having two types of winding, stator winding and rotor winding. Whenever we can give a 3-phase AC supply to this stator winding, then it can produce a rotating magnetic field in the air gap between stator and rotor, because whenever a 3-phase R phase, Y phase and B phase are 120 degree phase shift, so the rotating magnetic field is rotating by electromagnetic induction. So it can produce a EMF into the rotor circuit also, so it can give a torque to the rotor. So in this way the induction motor can be work. Okay, So if we have to define the induction motor, then it is an AC motor and it work on principle of electromagnetic induction. Now if we have to see the construction of induction motor, then you can see in the animated view we have shown one AC motor. Okay, in this AC motor you can see fan, stator. Okay, this part is shown by some animated view. So whenever some linings are on these motors, so that motor is called as AC motor, induction motor. And whenever there is no any line of linings in the motor, then it is called as a DC motor. So in this animated view you can see that is a induction motor. Now in this another animated view we have shown a different parts of induction motor. So if the part is like fan, stator, rotor and then starter also, because AC motor require to start. So that's why you can see in the figure that are the different parts. Whenever you see from the front sides, then every part is connected in this way. Okay. Stator, that is a stationary part that cannot be rotate, and the rotor, that is a rotating parts. Okay, you can see in the animated view that is a construction of induction motor drives. Now if we see the working of induction motor, then it will be work on the principle of electromagnetic induction by Faraday's law of electromagnetic induction. Now if we see the how it can be a rotate, then in this animated view you can see induction motor, there is a two part, stator that is a stationary part, okay, and the rotor that is a rotating parts. So whenever we can give a three phase AC supply to the stator winding, R phase, Y phase and B phase, so we know that a three phase are 120 degree phase shift with each other. So whenever this three phase supply is given to this stator windings, then stator winding produce a rotating magnetic field in the air gap between stator and rotor. Okay. So due to this rotating magnetic field, by Faraday's electromagnetic induction, some kind of EMF is induced in the rotor circuit. Okay, and rotor circuit is short circuited by end rings. So whatever the EMF, that is due to this EMF, it can be work like a potential difference. Okay, so some kind of current in flow in the rotor circuit, and due to this current it can produce some kind of torque. Okay, and you can see in the rotor figure, some linings are not exactly parallel to each linings. In the rotor construction you can see linings are given by skewed. Okay, skew linings are given. These skew linings are given because there is not produce the magnetic locking. Okay, to reduce the magnetic locking, we have provide this kind of screwed angles linings. Okay, that is called as a rotor slots also. Okay, these slots are not exactly parallel, but it having some kind of skewed. Okay, and also it will be not like a solid body. It is made of different kind of stampings to reduce the eddy current losses. Okay, so that is a construction. And now if we want to see the working, then you can see this kind of three phase AC supply, and this kind of rotating magnetic field is produced in the rotor circuit. Okay, between the stator and rotor circuit, that's why it can produce EMF into the rotor circuit. So that is the working principle of induction motor drives. So that are the some basics of this chapter that you have already studied in the electrical machine also. That's why we have only revised this topic. Now the introduction. Okay, the chapter introduction. In the introduction we have to see a speed of induction motor is very near to its synchronous speed, and changing the synchronous speed result in speed variation. Okay, we know that in the induction motor, speed that is given by the synchronous speed ns, okay, and it is near to the synchronous speed, because ns, that is a synchronous speed, but actually the induction motor will be rotate on the speed of n. So we have give the equation like slip s is equal to ns minus n divided by ns. So we can say that induction motor speed is very near to the synchronous speed. So changing the supply frequency varies the synchronous speed. So that's why we can vary the speed of induction motor. So if we have to see the relation between synchronous speed and the frequency, then the relationship is ns is equal to 120 f divided by t. So that is the equation where we can say that ns, that is the synchronous speed in rpm, and fs, that is the supply frequency. So if we have to vary the supply frequency, then synchronous speed is vary, and synchronous speed is related with the induction motor speed. So we can vary the motor speed. So that is a basic introduction of this chapter, how we can vary the speed of induction motor. So in this introduction, you can see we have discussed the basic speed, okay. ns is equal to 120 fs divided by p. Now the first topic, that is a frequency changer, static frequency changer. So here we have first topic, that is a classification of frequency changer circuit. If we have classified the frequency changer, then the frequency changer circuit can be classified in the two manners. First, that is a direct method, and second, that is a indirect method. A frequency changer circuit can be classified as a direct and then as an indirect method. In the direct method, it can be classified as a cycloconverter, okay. If we have to vary the frequency by direct method, then we can use a cycloconverter, okay. And indirect method, we have two types, that is first voltage source inverter, and second, that is a current source. These two kind of types. Then voltage source can also classified as a pulse width modulation, okay. And second, that is a variable voltage variable frequency, VVVF, variable voltage variable frequency drive, okay. Then current source also can be classified as a auto sequentially communicated inverter and pulse width modulation. So that is a classification of a frequency changer circuit. So here we have to discuss this wall, direct and indirect method, voltage source method and current source method. So first of all, we will discuss the direct method, okay, a static frequency changer with a direct method. So if we have to provide a direct method, then it is known as a cycloconverter that convert AC supply of utility frequency to a variable frequency. So if we have to define the cycloconverter, then a cycloconverter is a device that convert AC supply at one frequency to AC supply at another frequency, okay. Voltage magnitude is same, but there is a change in frequency. So a cyclo, that means word, that is frequency. Cycloconverter, that is a frequency converter, okay. So a cycloconverter is a device that convert AC supply at one frequency to AC supply at another frequency, okay. Now the cycloconverter for a single phase circuit of anti-parallel dual phase control converter, okay. If we want to see the circuit for cycloconverter, then cycloconverter basically anti-parallel connected to HCR, okay. We already discussed in our power electronics also. A cycloconverter use a power device, that is a triac, okay, to anti-parallel connected HCR, okay. Then it can be a single phase or three phase control converter. We can say that it cycloconverter may be a three phase or single phase. if we want to see the figure for cycloconverter, in this figure you can see here that is two back to back connected HCR is connected here, okay, and that is a cycloconverter figure. We can say that two back to back HCR, that means its circuit is like a triad, okay, and the input is cycloconverter, that is a three phase AC supply, okay. So we can say that the input, that is a three phase single three phase AC supply, and the output that is connected to the induction motor or a synchronous motor, okay. It is another types of AC motor, so we can say that are the two AC motor, okay. So in this figure you can see we have not provided any kind of indirect method, okay. We have directly connected cycloconverter to convert AC supply at one frequency to AC supply at another frequency to the induction motor. That's why induction motor can vary the speed, okay. The basic our funda is to vary the induction motor speed or to control the induction motor speed, okay. So we have provided cycloconverter to vary the frequency. So if frequency is varied, then speed also vary, okay. Then the next topic, that is a frequency changer circuit with indirect method. Now we have provided the indirect method to vary the speed, okay. So in the indirect method, it consists of first rectification by AC to DC, then it will be an inversion of DC to AC power conversion stage, okay. So indirect method, so we have first convert AC supply into DC supply by rectifier, then from DC supply to its AC supply by using inverter like PWM inverter, voltage source inverter, okay. So in this figure you can see first we have provide a diode rectifier circuit, okay, or HCR rectifier circuit, okay. If we have to provide the control rectifier, then we have provide HCR. If we have to provide diode rectifier, then also we can provide rectifier circuit. Then another, that is a PWM inverter, okay. In this figure you can see we have provide two one rectifier and another, that is inverter. Then input to the rectifier, that is a three phase AC supply, okay, and output, and also we have provide connection between this, that is by capacitor, okay, to maintain a constant DC voltage across the PWM inverter. That's why we can provide the capacitor, okay. Whatever the three phase AC supply is converted into the DC supply, this DC supply is constant is given to this inverter, okay. So here we can connect the capacitor, that is voltage across capacitor, that is VDC, and here output, that is an induction motor. So that is a PWM inverter based induction motor drive, okay. Here you can see we have provided the indirect method to convert AC supply to a variable AC supply, okay. Here we have not varied the frequency, because here whatever the frequency at the input, wherever it will be rectified, frequency will be 0, and again it will be converted into AC supply by using PWM method. So that times voltage will be vary and frequency will be vary. So in this method we can say that variable voltage and variable frequency method, okay. So that is an indirect method of speed control, and here that is a DC link filter, we can say that. And if rectifier is uncontrolled and voltage its frequency are controlled in pulse width modulated inverter, okay. We sometimes we can use uncontrolled rectifier also here. The DC link filter consists of capacitor to keep input voltage to the inverter constant and a smooth ripple in the rectified output voltage. So that we have already explained, a DC filter is provided to maintain a constant DC supply with some kind of ripple content is removed by the capacitor. So that are the two topics of this chapter: static frequency changer in direct method and the indirect method. So the next topic, that is a voltage source inverter, different types of voltage source inverter, PWM methods and also speed control methods. So that we will discuss in our next session. Okay, thank you.